Introduction to polar coordinates. A point P in the plane, like this one, is represented by the polar coordinates r theta, where r is the directed distance from a point called the pole. So this would be the point called the pole, and we have r as the directed distance from that point. Directed meaning it could have a sign. And theta is an angle measured from a ray called the polar axis. So we have the angle theta measured from another ray called the polar axis. That angle theta is from the polar axis to the line segment from the pole to P. So there's the line segment from the pole to P. There's the ray called the polar axis. There's the angle theta measured from the polar axis to that line segment. And there's the distance r between the pole and the point P. We have a whole coordinate system that's based on this called the polar coordinate system. And the polar coordinate system consists of these concentric circles and the terminal sides of different angles. These angles are going 15 degrees at a time. This specific point has a distance from the pole of 1, 2, 3, 4, 5, and an angle. Well, the terminal side that we're on is the terminal side of 2 pi over 3. So in polar coordinates, this would be the ordered pair 5 comma 2 pi over 3. So there's some nuance to this. Let's take a look. The point P equals r theta is located the absolute value of r units from the pole. If r is positive, then the point lies on the terminal side of theta itself. On the other hand, if r is negative, the point lies on the ray that forms a straight angle with theta. So for negative radiuses, we are going to go to the ray that forms a straight angle with theta and go the absolute value of r units from the pole on that ray. So let's plot some polar coordinates. Here we want to plot the point with the polar coordinates 3, negative 255 degrees. So first I need to find the angle negative 255 degrees, which is this angle here. This is the terminal side of that angle. Negative 255 is 15 degrees shy of negative 270. And then once we know what the ray is that we're going to be on, we're on the terminal side of the negative 255 angle, we just need to be 3 units from the pole. So from the pole I go 1, 2, 3 units along that ray, and that's where the point A is. So I put a point there, that's point A. And that's how you plot a point in polar coordinates. So there's point A. Let's go ahead and plot this next point, point B. You'll notice that point B has a negative radius. So that means that the point we plot is not going to be on the terminal side of 5 pi over 3, but on the ray that forms a straight angle with the terminal side of 5 pi over 3. So first we'll find the angle 5 pi over 3, and here's that angle right here, 5 pi over 3. This is the terminal side. So now I need to go 5 units, but not along this terminal side. I actually need to extend this terminal side to make a straight angle. So here's the straight angle, and this is where I'm going to graph the point on this line segment here that's 180 degrees or pi radians away from the terminal side of 5 pi over 3. So I'm on this line segment and I need to be 5 units away from the pole. So that's 1, 2, 3, 4, 5. This is where the point is going to be. So once again, when you have a negative radius, instead of plotting the point on the terminal side of that angle, 5 pi over 3, you need to extend a straight angle through the pole and then plot that point the absolute value of r units away from the pole along that extended line segment. So let's try and graph this point C that has both a negative angle and a negative radius. So first I'm going to find that negative angle, negative 19 pi over 12. Well, positive 19 pi over 12 is here just beyond that 270 degree quadrant angle, or that 3 pi over 2 quadrant angle. So if I'm going in the negative direction, I'm going clockwise. Here's that 3 pi over 2 quadrant angle. I just need to be on the next ray over. This one right here. This ray would represent an angle of negative 19 pi over 12. But because the radius is negative, I'm not going to plot 2 units up here. I'm actually going to go across the pole onto that other side of that straight angle, and I'm going to go 2 units from the pole on that side. This is where the point is going to be, point C. So that's how you plot points in the polar coordinate system. And these are the 3 points that we have plotted. What I want to do next is I want to look at converting between rectangular and polar coordinates. Here we have the conversion formulas. The first 2 conversion formulas allow you to convert from polar to rectangular because you're given an r and a theta, and you can use that r and theta to find x and y. The second 2 are going to allow you to convert from rectangular coordinates, x's and y's, to polar coordinates, r's and thetas. So the first 2 are from polar to rectangular, and the second 2 are from rectangular to polar. And here's the geometry of everything. X is just the horizontal distance from the origin to the point. Y is just the vertical distance from the origin to the point. R is the distance from the pole to the point. And theta is the rotation from the positive x-axis to the terminal side of the angle that contains the point. Find the rectangular coordinates of the point with polar coordinates -5, 5 pi over 3. So they've given me r as -5, so that's r, and they've given me theta as 5 pi over 3 radians. So I have the value of r and theta, and I can use those 2 values to find x and y with these first 2 equations. So first I'll have x is equal to -5 times the cosine of 5 pi over 3, and I can type this into a calculator, or we can remember that the cosine of 5 pi over 3 is 1/2. Either way, we get that x is equal to -2.5. Next, we want to go ahead and use this other equation to find y. So y is going to be r times the sine of theta, or -5 times the sine of 5 pi over 3. Typing this into a calculator, we get that y is approximately equal to 4.33. I rounded that to 2 decimal places. For this set of polar coordinates, the rectangular coordinates would be -2.5, 4.3. So that would be the final answer. All right, let's do one more example. Here I have some rectangular coordinates, and I want to find the polar coordinates of the ordered pair -7, -3. Well, here they're giving me an x value of -7 and a y value of -3. Since these are rectangular coordinates, I'm going to use those 2 values to find the values of r and theta. And here are the 2 equations, the 2 bottom ones here, that I'm going to use to do that. So to find r, if I solve this equation for r, I get r is the square root of x squared plus y squared. So that means that r is the square root of -7 squared plus -3 squared, which is the square root of 49 plus 9. Square root of 58 is approximately 7.6. The other thing I have is I have that the tangent of theta is y over x, which says that the tangent of theta would be 3 over 7. -3 over -7, the negatives cancel. Now, because this point is in the 3rd quadrant, the arctangent function is not going to be able to give me this specific angle. So what I need to do is I need to take the angle that the arctangent gives me and add pi to it, because the angle that has the same tangent as -7 comma -3 is the point +7 comma +3, which is in the first quadrant, and 180 degrees off from the point that we actually want. So all we have to do is add pi to the answer that the calculator will give us, and we get that the angle theta is 3.5465 radians. So that the ordered pair in polar coordinates, this ordered pair would be 7.6 comma 3.5465 radians. And that is the final answer.